So here we are, 3.3, polynomial division, the remainder and factor theorems in college algebra on page 281 of your book. Just want to make sure that you're reminded of some vocabulary terms when it comes to dividing and what we've got here. So when we're doing a math problem, we've got the divisor, the quotient, and the dividend, and down here we've got the remainder. Now, one of the things that you learned a long time ago when you were doing division, like dividing 4 into 237, is you would do the math, you'd get an answer of 59 with a remainder of 1, and then you were asked to check your math. So what you ended up doing is you took your quotient, you multiplied it times your divisor, and then once you did that, you added your remainder. And if you got 237, which is your dividend, then you did it correctly. So you multiplied this times this and added your remainder there, and that should give you your dividend. Okay, so those are very, very important things to remember in this next lesson because it will determine factors of polynomial functions. So let me go ahead and get rid of all of this, and you've got that in your notes. So let's go ahead with an actual polynomial. Okay, so looking at example 1 on the bottom of page 281, we have this polynomial function being divided by x plus 1. And as we do the math to go ahead and factor this down, x goes into x to the cubed, x squared times, so let's put a 2 up there, and then we multiply, and we get this, then we subtract, and we get x squared, bring down the 5x, and then we get plus x up here, and we multiply. I'm assuming you know how to do all this since this is old stuff. Negative 6x, bring down the 6, divide, minus 6, multiply, negative 6x minus 6, and we get 0 for a remainder. Okay, whenever you get 0 for a remainder, when you do division, it tells you that your divisor is a factor of your dividend. So for example, if I were using real numbers and I said 5 into 100, well, 5 goes into 10 twice, 10, bring down the 0, and I get a 0. So I get 20 for an answer with a remainder of 0. So that means 5 goes evenly into 100 20 times. There's no remainder. So I know then that my 5 is a factor of 100. Same thing true of a polynomial. If I divide x plus 1 into this dividend right here, and I get 0 for a remainder, I know that this goes into this, x squared plus x minus 6 times. It goes into it evenly, which means x plus 1 is one of the factors of x cubed plus 2x squared minus 5x minus 6. All that to say is that, let's see if we can erase some of this. I can't. Okay, all that to say, and I'll put it down here at the bottom, x plus 1 times x squared, this is the quotient, plus x minus 6, plus the remainder, which in this case is 0, will equal x cubed, my dividend, 2x squared minus 5x minus 6. So, to check, again, you would multiply your quotient times your divisor, add the remainder, and you will get your dividend right here, just like we did when we were doing this. 20 times 5 is 100, plus the remainder of 0 equals 100. So that means that these two factors are factors of this here. Now watch what we can do here once we discover that. That being the case, then we can actually say that these two go evenly into this, and we can even factor this down even more because a factor of this will also be a factor of this. So if we take this and we go x and x, and we have a 3 and a 2, and let's say that's a plus and that's a minus. So now we have just factored this down into this. So x plus 1, x minus 3, and x minus 2, all three of these are factors that will go evenly into this polynomial function. Which also means, once we have it factored like this, my roots, or where this graph crosses the x-axis, will be -1, -3, and +2 from my factors that I have right here. So just by dividing this by x plus 1 up here, I was able to find out the roots or the zeros of the polynomial function as far as where it crosses the x-axis in order to graph. If I divided x plus 1 into this and I got a remainder, that means this is not a factor of this. It would mean this does not divide evenly into this. So, for example, if I had a math problem with just regular numbers and I said 27 divided by 4, and I did the math and I got 6, 24, 30, or I'm sorry, not 30, 3, I'd get 6 with a remainder of 3. So what that tells me is that 4 does not go evenly into 27. There's some left over. So when I get a leftover like that, I know that 4 is not a factor of 27. It goes into it, but it's not a factor. It does not go evenly into it. So if I got a remainder down here, that would tell me that this did not go evenly into this. If I get a 0 as a remainder, then this goes evenly into this, and I can say that x plus 1 is a factor of this, and therefore -1 is one of the roots or the zeros of this polynomial. That's one place where this graph crosses the x-axis. So in this particular problem, having a 0 as a remainder, I know lots of things. I know that this x plus 1 is one of the factors, and I know -1 is one of the roots or one of the answers. Okay, so let's look at this one. If I were to do all the division, I would get x squared plus 5x plus 10, and I would get a remainder of 24. That is a key part of this problem, because if I get a remainder, that means x minus 3 is not a factor of this, and that means +3 is not a root, or it does not cross the x-intersection there. Okay, so if I give you a polynomial function, your problem is, what am I going to find out? How am I going to factor this so that I get no remainder, so that I know that my divisor is a factor of my dividend here? Because you could just grab x minus 3, x plus 2, x minus 14, or whatever you want. You'd have to try every one of them until you get a remainder of 0. So you can say, okay, this divisor is a factor of my polynomial function. So that's one of the tricky things, is what am I going to divide here to find out what my factors are? And that's one of the things that we're going to be talking about. So, middle of page 282, one of the things they say is that in order to be a factor, your remainder must be a 0. And another thing they say here in their formula is that p of x, so my polynomial function, is going to be equal to my divisor times my quotient plus my remainder. And that's exactly what we've said all along. When we do this, we take our divisor, multiply it by our quotient, add our remainder, and when we do that, we will get our polynomial function, which is what this p of x represents. Okay, so it's just like any other math when you're checking your answer. This times this plus your remainder is going to equal that. What we're hoping for is that our remainder is 0, so it's just this times this equals this, which means that this and our quotient are both factors of our polynomial function that we have right here. So that's what we would like it to be. Okay, let's look at something kind of crazy. All right, if we were to divide this polynomial function by x plus 1. So if we were to divide that, and let's see if I can do this. Stick that in there. So if we were to divide that by x plus 1, we would get, for a remainder, we would get 0. So we would get, now let's not worry about anything else, let's just worry about the remainder being 0. If, on the other hand, we were to divide this polynomial function by x minus 3, we would get a remainder of 24. So we'd get a remainder of 24. So x minus 3 we would realize is not a function, or is not a factor of our polynomial function, because we got a remainder of 24 in our answer, and we can't have a remainder if it's a factor. Now let's try something else. Let's take, and let me move some things here. Okay, so let me say that again. When we plug in, or when we take x plus 1 and divide it into our polynomial function, we get a remainder of 0. When we plug x plus 3 and divide that into our polynomial function, we get a remainder of 24. So that means this is not a factor. If we were to take the root of this, which is -1, and we were to plug -1 in to our original polynomial function, we'd get -1, and we'd put -1 there, and we'd get a plus 2, and we'd get a plus 5, minus 6. We would get, for our h of x, or our h of -1, when we plug -1 into our equation, we would get an h of -1 of 0, just like we got with our remainder. If we were to take 3 and plug it into our original equation right here, we would get, for our function, when we plug 3 in, we would get 24. So what we're finding out is that when we take a factor, one of our factors, x plus 1, if we knew it was a factor and we plugged it in here, we would get a y value, or an h of -1 of 0. So actually, we don't even have to do the division. We can just pick a number and put in here, and if it gives me a y value, or an answer of 0, then we know that x plus 1 is a factor of this. When we put the 3, what would be the root, or the answer, in here, and it spits out a remainder, we know that x minus 3 is not a factor. So that leads me to say, if I had x plus 6, and I plugged a -6 in my equation up here, and let's say I got a remainder of 0, well then x plus 6 would also be a factor of this. So all I'm doing is plugging the root, whatever makes this 0, into this equation, into this polynomial function here, and if I get a remainder, then it is not a factor. If I get a remainder of 0, then it is. So one of the things that we realize is that my remainder and my y value are the same thing. See, I got a remainder of 24. I plugged 3 in there. It gave me a y value of 24. So therefore, this is not a factor, because when I plug in 3, I get a remainder. When I plug in -1, I do not get a remainder. Okay? So we're going to use this bit of information we did to discuss the remainder theorem. Which brings me to what we call synthetic division. Now we've talked about this before, but you are going to use this lots and lots and lots, because you're going to be trying to find factors of equation or factors of polynomials, and the only way to do this quickly and efficiently is to use synthetic division. Okay, so again, I'm going to give you the rules for it. You're going to have to write them down, because I'm just going to say them once because you have access to this video so you can watch it over and over and over again. So what I'm going to do is I'm going to take whatever is going to make my, in this case, my divisor 0, which here it's going to be a 2, and I'm going to put it in a little box here. Then I'm going to look at my dividend, and I'm going to take each constant of my dividend here. Okay, so 4, -3, 1, and 7, and I'm going to write them down. Then I'm going to draw a line, and I'm going to bring down my 4. I don't do anything to it. Then I'm going to multiply my 4 times my 2 and get 8, and that answer will go up here. Then I'm going to add these together and get 5. Then I'm going to multiply 2 times 5, and I'm going to get 10, and it's going to go right here. And then I'm going to add. Then I'm going to multiply 11 times 2, and I'm going to get 22, and I'm going to add. The last number will always be your remainder. So if you get a 29, if you get any number except 0 is a remainder, then you know that x minus 2 is not a factor of this polynomial here. If you get a 0 as this last number as your remainder, then you know that this goes into this evenly. So it's a really, really quick way to figure out whether or not your divisor here is a factor of your dividend. You don't even really need to write the answer down, because I really don't care what the answer is here. The answer actually would be 4x squared plus 5x plus 11 plus 29 over x minus 2. So you end up getting an answer that's a mess. We don't even care what that answer is. All we care about is, did I get a remainder of 0? That's all that matters. Okay? Okay, a fancy little trick here. Kind of alluded to it a little bit ago, that our remainder in our division and our y value are going to be the same thing. So let's say that I want to know what f of 10 is. That means, what is my value if I put as x 10, what is my y value going to be? So how can I plot that point? Well, normally what you've been doing is you've been taking that 10, putting it in here, taking it to the 5th power, multiplying it by 2, minus 3 times 10 to the 4th power, plus 10 cubed, minus 2 times 10 squared, plus 10, minus 8. A big, big mess. What you can do is you can do synthetic division, or you can use the remainder theorem, and because you know that the remainder is the same as plugging the 10 in here, we can just do synthetic division. So I'm just going to go 2 minus 3, 1 minus 2, 1 minus 8, and in the box I'm going to put 10 in here. I'm going to bring down the, oops, wrong place. Bring down the 2 here, put a 20. Add, multiply. Add, multiply. Add, oops, I should be at 10. 1708 here. Multiply. Add, multiply. And I know right here when I add, I'm not going to get a 0. It doesn't matter what number I get here. If it's not a 0, then I know this does not go into it evenly. But I was interested at this point in finding out what this number is because the remainder is the y value. If I were to take, that's kind of a silly looking 2. If I were to take 10 and put it in here, I would get this for an answer. So using this synthetic division or this remainder theorem idea, that my remainder is going to be the same as if I were to take this and actually put it in there, this is a lot easier to do than plugging a number into there. So that's a nice way to do that. So one of the things you can do really quick and easy then is you can decide whether a number very quickly is a factor. So let's say that I have an f of x of x cubed, here's my polynomial function, and I want to find out if -4 is a 0 to this. Does this graph cross at x equals -4? Well, all I have to do is take -4 and plug -4 in here, in here, in here, and get an answer. Or, and my answer needs to be 0, right? Because if I get 0 for my y value, when I graph this at -4, it's going to go up or down 0. So I know it's going to be an actual factor of that equation. The other option is to make my box, put -4 here, write my coefficients, 1, 8, 8 for the 8x and the -32, and draw my line here, bring down my 1, multiply, add, multiply, add, multiply, add, and I get 0. So because I got a 0 for my remainder, then I know f minus 4, or I know that -4 is a factor, and that's where it crosses the x-axis, which also tells me x plus 4 is a factor of this. Because if -4 plugs in and gives me a remainder of 0, then -4 plus 4 is 0. Whatever makes this 0, which in this case we put a -4 in here and it makes that 0, that means that this is a factor of that, which is real nice to know too, and we will be learning that in the next section. Okay, here we go with something crazy. This is example 5. What we're interested in here is whether or not the imaginary number I is a factor of that, or is a 0 of f of x, I guess is what I should be saying. So we're going to do it the same way. We're going to make a little box, put I in here. We're going to put a 1, a -3, a 1, and a -3. Bring down our 1. 1 times I is I. -3 plus I is -3 plus I. Multiply that by I, and we get, let me see, we get I, we get -3I minus 1. We add those. Multiply. We get 0. So this is a root of the equation. Okay, so again, let me just go over it. We bring down our 1. I times 1 is I. We add these. You can't combine those, so you got to leave it as -3 plus I. Multiply that by I. So we used distributive. We've got I times -3 plus I. So we get -3I plus I squared, which is -1. So that's where I got -3I minus 1 here is from this. I changed that to a -1. I add these. Well, 1 plus negative 1 is 0, which leaves me with just negative 3i right here. Negative 3i times I is going to be negative 3i squared, and if you remember, I squared is negative 1. That gives me a positive 3, which went there. Add those two together and I get 0. So again, I don't care what this is. I only want to know whether I get 0 for a remainder, because if I get 0 for a remainder, that means that I is a 0 of the function. Okay? It means it goes evenly into this polynomial function. Okay, so the next part has to do with the factor theorem, and what we're doing here is we're trying to find out, given this polynomial function, what might be what might be all of the factors here. Okay, so I'm not looking for the zeros, I'm looking for the factors, because once I have the factors I can find the zeros. So for instance, if my factors were x plus 1 times x minus 2 times x plus 3, those are my factors, and I know that my zeros then would be whatever makes each one of these factors 0. So I find two things. I find the factors, and then that gives me the roots. All right, so let's look at how to find the factors. Well, let's just do it. We're going to do in this section trial and error. In the next section, we will be in 3.4 learning some kind of tricks in order to find out if things are factors. So let's just say we want to try and see if x minus 1 might be a factor. So in order to do that, we make our little box. We put a 1 there, whatever is going to make this 0. When we do this part of it, what makes x minus 1 0? 1. 1 minus 1 is 0. And then we put a 1 here, a 2, a negative 5, and a negative 6. And we're just going to do our division. And we bring down our 1, we get a 1, we get a 3, we get a 3, we get a negative 2, we get a negative 2. I don't even have to go on because I know this is not going to be a 0. So I know that doesn't work. So I erase all this. And it's like, okay, well, let's try another number. Instead of 1, let's try x plus 1. Maybe x plus 1 is a 0. X minus 1 wasn't. So then we make our box, and we put a negative 1 in there instead. 1, 2, negative 5, and a 6. Bring down a 1, negative 1, a 1, a negative 1, a negative 6, okay. That makes this a 6. Oops, this is negative 6. That makes it a 0. So I know that that is a factor. Okay, so what I do is I say, okay, that is one of my factors. What is another factor? Another factor is this answer here. So in order to write my other factor, I look and see that my 1 is associated with here. My 2 was associated here, negative 5 here, negative 6 here. So what I do is I make this one on my new x value, and it will always be 1 less than what I started, because one of my x's is over here. That gives me x cubed. So now I'm going to go down 1 to x squared, and I'm going to put my next x with x, and I'm going to put my minus 6 all by its lonesome. So this is the way of writing this with my answers, because I've got to put my variables back in there, because I was just working with numbers here. So I put my variables back in. This will always be 1 less than what we started here, and it will always work its way down. So now I've got, in fact, let me make my x plus 1 here, and I'm going to break this x squared plus x minus 6 into two binomials, because I can do that. Take an x there and an x there and a 3 there and a 2 there and a plus and a minus, and I'll put my x plus 1 here that I've got right here. So there are 3 factors that will go evenly into this and work just fine. So now that I have that, I also know that my roots are negative 1 for this one, negative 3 for this one, and 2 for this one. So I found my factors, and then I was able to find the roots of the equations of negative 1, negative 3, and 2. So that's how you do it by trial and error, and that's what we're going to do in this section. And then the next section we'll come up with a way to make it so you are at least not just grabbing possible factors out of thin air. At least you have some educated guesses that you can do. So that is all to 3.3.